Hi, my name is Brandon Graisley. I'm a high school math teacher, and I'm going to go through some solutions for this practice test for my class. Here we have what is the value of each function below when x equals -3. So we're going to substitute that into each of these two equations. So f of -3 is 1/3 times -3 plus 1, and -3 minus 5 there. We're going to just simplify everything and write down a final value. Here we have -2, -8, so together that's 16/3. Over here for the function g at -3, -3 times, in brackets we have -3 minus 1/2, that is squared, and then subtracting 3. Important that we're going to simplify what's in here and then square it before multiplying by this -3, so we're going to leave that right there. This is -6/2, so that's -7/2 altogether, which is squared, minus 3. When we square this, we're going to get positive 49 on the top and 4 on the bottom. And I'm just running out of space here. -3 times 49 is -147, and then we have another 3 here to subtract. That's the same as 12 quarters that we're subtracting, so that's going to be -159 over 4. So multiply these two and then subtract 3, and that's going to be some fraction work. Okay, let's go on to this question here. Write the domain and range for f of x using set notation. So this has a vertex of +4, +7 from here and here, and it opens up. So from 4, 7, we know that we're going to get y values from 7 on up and nothing below 7. And the domain for every quadratic is the set of all x values that are real numbers, and the range then, y values that are real numbers as long as y is greater than or equal to +7. Here we have a quadratic with this vertex and a given x-intercept. That's another point. What is the other x-intercept? Let me draw a little sketch here. Here are my axes. Let's say the vertex is about here, 3, 6. The intercept 5, 0 is about there. Vertex is at 3. Now that's 2 away on one side, so 2 away on the other side right here at 1 would be the other x-intercept. So at 1, 0, because parabolas are symmetrical. Oops, I missed. Write the equation for f of x in any form. Well, we can use vertex form or factored form because we do know both of the roots. I'm going to start with vertex form. I'll write factored form at the end. So f of x is, well, in regular vertex form we have something like this, with the parameters a, h, and k. A is the vertical stretch or compression factor, which we don't know yet. We can't tell just from looking at these points. We do know h and k, the x and y values of the vertex. So here we have a partially completed equation with 3 for h and 6 for k. Now we know two other points, 5, 0 and 1, 0. I'm going to use 5, 0 since it was given to me. If I made a mistake figuring out 1, 0, I don't want to use that one. So we know f at 5 is 0. That's a key fact. So let's substitute that in. 0 is the y value, or the value of the function. We don't know a yet. 5 is the x value. And continuing from there, we have 0 is a times, that's 2 squared. Let's see, that's 4a plus 6. And rearranging this, we get -6 is 4a. -6 over 4 is a. Squeeze this in. -3/2 is a. So we can now write the complete function in vertex form first. There's 3/2 for a, x minus 3 squared plus 6, or in factored form, we use the same a value, because that describes the shape of the parabola, and I can use x minus 5 from the one root and x minus 1 from the other root. Okay, let's keep going. Describe all of the transformations applied to the graph of f of x equals x squared, that's the parent function for parabolas, to get each of these g of x's. So we have 3 of them. So this one has, let me just grab a color here. This one has 3 things happening. We have a minus sign on the a value. We have the number 2 as part of a, and we have this number 1. So this one causes a vertical reflection. The number 2 causes a vertical stretch by a factor of 2. And here we have a vertical translation, and that's going to be up 1 because it's a positive 1. Taking a look here at the second function, we have, oops, I was using arrows. Oof, terrible arrow. We have 2 things happening here. 2/3 is our a value. That is less than 1 between negative 1 and positive 1. So this is a vertical compression by a factor of 2/3. And this is a horizontal translation because it's affecting x before it gets squared. Horizontal translation, this one is to the left 5 units. And here we have a negative sign there on our a value. We have a horizontal translation and a vertical translation. So this causes the vertical reflection. There's no stretch or compression. This is a horizontal translation, this time to the right 4 units. And this one is a vertical translation down 6. Okay, let's draw a graph of this function f of x and its inverse. Now let's just analyze this a little bit. Here we have negative 4 is the h value, and positive 3 is the k value. So that gives us the vertex, negative 4, positive 3. I see that it opens down because of this negative sign, and it's been compressed vertically. So let me just do a quick sketch. I didn't bring a ruler with me, so I guess you'll get the best I can manage. Negative 4, positive 3. Just start with some axes. Okay, and negative 4, positive 3, I'm just going to use a 1-to-1 scale here, but I'm not going to write the numbers on because I don't want to clutter things up for you to see here. Now I have a scale or a vertical compression of negative 1/3. So you've got a couple ways to try to figure this out. One is to use a step pattern. There's like a 1, 3, 5 pattern, so you can go over 1 and down 1/3 in this case. So that's a possibility if you want to do that. And then it would be from there over 1 and down, normally 3, but it's 1/3 of that, so down 1. And then over 1 down 5, in this case 5/3, which actually takes us right to the x-axis. Another option is to grab a calculator or just do some mental math to figure out what each of these, what some of the coordinates are. So for example, what happens when I get to the y-axis here? That's when x is 0, so I can type in negative 1/3. I'll use brackets to type in 0 plus 4, or just 4 squared, and then plus 3 at the end. And I have negative 7/3, or that's negative 2.33 and change. So that's right there. Now I've got a pretty good graph ready to sketch here. Definitely should have grabbed a pencil and a ruler for this. Oh well. Okay, not too bad. Now we want to draw the inverse. The inverse has exactly the same x and y values, except they've been reversed. The y's are the x's and the x's are the y's. I'm just going to draw a little dashed line here through the line y equals x, because the inverse is a reflection in this line. Another option is to come up with the equation for the inverse, and to which will be kind of like a square root thing, and you can sketch that if you know how to draw square root functions. So I'm going to start instead, let me grab another color, by plotting the points that have the opposite x and y values. So let's look at this point right here. This was 0, negative 2.33, and so instead we'll get negative 2.33 and 0, which is over here on this axis. This point was negative 1, 0, so instead we get 0, negative 1. And as we go, we're just going to plot enough of these points that you'll be able to see where things end up. Let's do the vertex. Negative 4, positive 3 becomes positive 3, negative 4. Negative 3, positive, this was 2 2/3, so positive 2 2/3, negative 3. Once you have enough of these points sort of copied over, and let's see, that was at negative 7. Just count that. Yeah, that's looking good. Then that'll be enough for you to sketch the graph of the inverse. And notice it just looks like a sideways parabola. Okay, here's another question that's similar to, I think it was number 3. We have a quadratic function with a given vertex. We know another point that it passes through. Write an equation for it. So because we know the vertex, it's a good idea to start with vertex form. If we knew the an x-intercept, for example, or both x-intercepts, we could use that form instead. So I filled in 3 for the h value, 2 for the k value, and we can use this other point that we know, 1, 4. 4 is the y value, 1 is the x value, and we just have to simplify this and solve for a. So that's going to be negative 2 squared. That's 4, so 4a plus 2. Let's see, 4 minus 2 on this side is 2, divided by 4 is a. A is a half, so I can use this equation. 1/2 x minus 3 squared plus 2 is our final equation. How many roots or x-intercepts, zeros, does each of these functions have? And you have to justify your answer. So this one right here, it's in standard form. I can't see instantly how to factor it or anything like that. So maybe I'll grab the discriminant. The discriminant, oops, did I spell that right? Sure. The discriminant is b squared minus 4ac, where that's a, b is negative 1, and c. Let's fill that in. So we have negative 1 squared minus 4 times 4 times 4. 1 minus, that's 64, negative 63. That's less than 0. That's a negative number. So there are no real roots. Over here, this one's in vertex form. And the vertex is positive 3, 0. Because you see there's no vertical translation up here, up or down. And so because the vertex is right on the x-axis, we can say there is one unique root. Maybe a quick sketch would help with that. The vertex is on the x-axis and it opens down, so it only touches in one spot. And this last one, this one is factored form, and the roots we can read directly from it are negative 1, 0 and positive 1, 0. Therefore, there are two unique or distinct roots. Okay, there's another option for this. If you didn't recognize these things, you could expand this and use the discriminant. You could expand this and use the discriminant. But it's really unnecessary when you know these vertex and factored forms. You just don't have to do something so complicated. You can visualize this if you want to. Here, let me draw a sketch of this one. It's at negative 1, positive 1, opens down like this. Okay, let's look at this last one on the page. For these two functions, f and g, write an equation in standard form for g of x in terms of x. Well, let's take a look. F of x is a quadratic. G of x is negative 4 times f of x plus 3 minus 5. So what we've got here, grab a color, is this is a function. It's not just x, and we would like it to not use the letter f, the function f, inside of this definition of g anywhere. So what we'll do is replace f of x plus 3 with whatever that means. And then we have a minus 5 at the end. So there's the negative 4 times f of x plus 3 minus 5. This is something a lot of people have difficulty with, so let's watch carefully how this works. F of x plus 3. Maybe I'll just write that up here. F of x plus 3 is 2 times, instead of x we have x plus 3, that's squared, and minus 8 at the end. So this is all going to be inserted here for f of x plus 3. 2x plus 3 squared minus 8. Now take a look. This has no f anywhere in it. It has an x. It's not in standard form. We need to expand and simplify all this. There's not a ton of space here, so I might have to combine a couple of little steps. 2 times, now x plus 3 squared is x squared plus 6x plus 9. And we have a minus 8 hanging out there. That's negative 4 times. I'm working on the inside here. I'm kind of leaving this negative 4 and negative 5 till the very end. Let's see, 2x squared plus 12x plus 18 minus 8, and then a minus 5 at the very end. Negative 4 times, let me simplify, 2x squared plus 12x plus 18 minus 8, that's plus 10. Then we have a minus 5. Multiplying now by negative 4, negative 8x squared minus 4 times 12 is 48. Negative 4 times 10 is negative 40. We have a minus 5 at the end. Negative 8x squared minus 48x minus 45, and that is the standard form for g of x. I made a boo-boo on this question, so part C doesn't make a lot of sense if you went through and tried to finish this, because it asks how much money would you lose, and you wouldn't lose money. The mistake I made was right here. This should be a minus sign right there. And I'm going to go through and complete this as though this was a minus sign, but I'll also work backwards on a couple of questions just to let you know what that would have been. So what is the maximum profit that this company can make? Oh, sorry, I should read the question. The company's profit in dollars is given by this equation, where x is the number of units of the product sold. So if you know how many units, you stick that number in for x, calculate this, you'll find the profit for that many units. Essentially, they lose money at the beginning until they've sold enough, but once the number of units gets very high, their costs also increase, and so they're not making money again. We have a parabola here opening downwards, and we want to find the maximum profit. The maximum profit occurs at the vertex, generally speaking. You have to graph it to see, I suppose, but we can figure it out here. The vertex occurs when x is negative b over 2a. That's the axis of symmetry, or you can get that from the quadratic formula. It's kind of the first half of the quadratic formula. Negative b is going to be negative 30, and 2a is 2 times negative 0.01. So that's going to be, you can just probably type that in a calculator, I guess, positive 1,500. So 1,500 units. Now that's not the answer. We want to know the actual profit, not just the number of units. So let's find P of 1,500. And this is where, if you have this minus sign here, you're going to get a different answer than if you have a plus sign. So negative 0.01 times 1,500 squared plus 30 times 1,500. And I'm going to use minus 12,500. And this is definitely calculator worthy. Grab a calculator to figure this one out, and that is 10,000. If you had done it the other way with a plus sign, you'd have, I think, 35,000 as an answer right here. And then once again, the difference is right there. What will the profit be if they sell 750 units? Just find P of 750. Profit at 750 units, and stick it all in there, and you get $4,375. Add 25,000 on that if you had a plus sign, so that's what, 29,375. Now, how much money will they lose if they sell 0 units? That would be P at 0, and this matters. If it's negative 12,500, 0 here, 0 here, these terms are gone, and we're left with this one at the end here. This is standard form. It's like a y-intercept. So how much money will they lose? They would lose $12,500. If you had the original question, this question doesn't make any sense. They would still be making money if they sold nothing, which is not really reasonable. Now for this last one, what is the break-even point? So here we need the x-intercepts to be able to answer this question. So to do that, we can try to factor it or use the quadratic formula, anything like that. Because this has decimals in it, you can just go straight to the quadratic formula. You can also set this equal to 0 and then multiply everything by negative 100. That'll clear out this decimal at the beginning. You'll get some pretty big numbers though. I'm going to grab the quadratic formula. It's really reliable. So negative b will be negative 30. I'm sorry, you can't kind of see this both at the same time. And then 30 squared minus 4 times a was negative 0.01, and c is negative 12,500. If you had positive 12,500, you're going to get something pretty different here. Okay. Squared, this comes out to, I already typed it in my calculator, square root of 400, which is a nice number, and negative 0.02 on the bottom. So we have x is negative 30 plus 20 over negative 0.02, or x is negative 30 minus 20 over negative 0.02. So this one comes out to 500, and this one comes out to 2,500. Now both of these are positive answers, which is nice. What is the break-even point though? The first point at which the profit is 0, because our sketch looks something like this. We want to know this point, which we've just found is 500. So the break-even point is 500 units. That's the number of units they need to sell before they become profitable. Doing great, almost there. We have 2 more parts in question 10. Find all the intersection points of f and g for each part below, or show that they do not intersect. So we have 2 functions. Both are written in the usual function notation. So we want to know, when does the first one equal the second one? And to do this, we're going to put everything into standard form and see if we can either factor or use the quadratic formula to help us out. So I'm just going to do that quickly. And that's going to be minus 5 halves. I think that's right. So 3x squared plus 1/2 x minus 5 halves. Okay, I have some fractions though. Fractions are not necessary here. I can't change the original functions, but once I have an equation like this, I can multiply everything by 2. 6x squared plus 1x minus 5 equals 0. And that feels very factorable to me. I'm going to try to do this. Let's see, 6x minus 5 and x plus 1. Squared minus 5x Yeah, that's going to work out. So you can also use the quadratic formula if you'd rather. Either way is fine. This factor gives us that x is positive 5/6, and the second factor gives us x is negative 1. Now, those are the x coordinates, but they don't tell us the y coordinates. We have to substitute those in. Let's substitute into g of x because it's the simpler of the two functions. So g of 5/6 is negative 1/2 times 5/6 plus 2. That would be negative 5/12. And 2 is 24/12. So that's 19/12. Okay, that's going to give us one of our points. G of negative 1 is negative 1/2 times negative 1 plus 2. That's positive 1/2 plus 2, which is 5/2. So the intersection points are 5/6 and 19/12. That's the first one. And the second one is negative 1 and 5/2. Oops, sorry, I'm just off the screen a little bit there. So once again, set the two equations equal to each other, solve for x. Here we have two answers. Substitute each one of those values into either of the original equations. I chose g because it was the linear functions, a little bit simpler to use. Okay, let's go on to the second one. F is the line, g is a quadratic. Let's set them equal to each other. Negative 3x minus 1 equals negative 2x squared plus 5x minus 9. I suppose I should have written something like, for the intersection point, this is what's true. We have a negative 2x squared on this side, so let's kind of get everything over onto the left. So positive 2x squared, let's see. Okay, that's where everything will be. 2x squared minus 8x plus 8 equals 0. Now I see that I have even numbers for everything. I can divide each of these terms, or both sides of the equation, by 2, leaving me with x squared minus 4x plus 4, and over here we have 0 divided by 2 is 0. Now this one's very factorable too. I happen to know this one because I notice that it's a perfect square. X minus 2, x minus 2, which means the only solution is that x is positive 2. I'll use f this time because it's simpler. F at 2 is negative 3 times 2 minus 1, that's negative 7. So the only intersection point is 2, negative 7. Okay, that is the end. If you have any questions at all, please feel free to ask anytime. Thanks.